Hi, and welcome to What Do You Want to Know Wednesday. This is the demonstration that I'll be doing on how to estimate the PEF factor in AMTS, or the physically effective factor, which is used to determine PENDF in the AMTS system. So what we use to do this is a Penn State particle box, and that's what this is here. This is the 3 sieve model on the bottom pan. This is a 19 millimeter sieve, an 8 millimeter sieve, importantly the 4 millimeter sieve, and then the bottom pan is down here. So what we need to do is we need to get a sample of our forage, and the forage should get as close as possible to what the actual as-fed form is, meaning you don't want to have a sampling device that makes very small particles like a core sampler. Even a large core sampler like this still can reduce that PEF artificially, and so it may not reflect what the cows actually see. So what we're going to do is make sure we have a forage sample to use. Today we're going to use corn silage. This is corn silage here, and it's actually quite a simple process. All we have to do is put forage on the pan, shake it, and it will sift down through, and then we can do some quick calculations at the end. So the recommendation is to use around 3 pints of loose forage. In this case, I'm actually going to start with the weight itself. This is going to be around 200 grams. Now you'll see at the end why I'm using 200 grams. I'm actually going to try to get exactly 200 grams. And I am going to not sort out my sample. I'm just kind of stirring it here, trying to make sure it's all well mixed. And as you know, corn silage tends to sift out or sort out, so you have to make sure it's well mixed when you take your sample here. So I'm just taking a few decently good-sized handfuls to make sure that I'm getting kind of a representative sample. I end up right around 202. And that's 200. Now, all I have to do is dump this on top. We might spread it out just for a little bit. And what we're going to do is we're going to shake the box horizontally. We want no vertical movement. This all needs to be horizontal. And we're going to shake the box 40 times. And so we want to do that in sets of 5. And so we will shake 5 times one direction, turn it a quarter turn, shake it 5 times, and then we'll do that again this way and this way. And then what we'll do is we'll make sure that we don't have any particles on top that are clumped together. So I'm going to have to pull that apart if we have that. And then we'll go around again. Okay? You can see on my box here I have a little mark to make sure that it, so I know which corner is my starting corner, that I don't lose track as I go. So what we're looking to do is have about a 7-inch stroke here, and around 1 shake per minute, or 1.1 hertz is actually the official recommendation. So we're going to try to achieve that. So here we go. Here, I would check to make sure I don't have any clumps. For corn silage, it falls apart pretty easily, but for something like a haylage, especially if it's fairly wet, you may want to make sure that that's pulled apart. And then we just go around one more time. Alright, and we're done. Now all we've got to do is weigh what's retained on each of the different sieves and write it up on our board here. So I'm going to take my cup, make sure it's empty, make sure it's zeroed on the scale, and then all I need to do is bring all my particles to one corner, try to make sure they don't fall through, and try to get as many as you can into the container. So, here we have 10 grams. Next up is the 8 millimeter sieve. Here is a good place to start looking for any kernels that you may see, in case you have a poorly processed corn silage. This one I do see a few little kernels here, so that's something I might want to discount, but I don't see very many. So for now I'm just going to keep moving. 96 grams. This is the 4mm pan. Anything from here and above is what we're actually going to use for our estimation of PENDF or PEF factor. Here is a good place as well to make sure you don't see any corn kernels. If you see corn kernels, you actually should try to remove them so that they don't get added in, because they don't contribute to the PEF factor at all. It's also a good way to have a conversation with your forage harvester runner, or the person that runs your forage harvester, or the custom outfit. So, okay. Here we are at 50 grams. Okay. And then our final pan, the bottom here. All right, and this is 44 grams. Now all we need to do is calculate what our PEF factor is, and actually to do that we'll just actually calculate the percents. So in this case, because I use 200 grams, what I'm going to do is I'm going to just divide these numbers by 2. That gets me to my percent on a 100 basis. So that means I have 5%, 48%, 25%, and 22% here. Okay. So to estimate the PEF factor, which is what you would enter into the AMTS program, and this is just as simply as a percent, all we need to do is do 100 minus 22. Okay? So in this case, we would say our PEF factor is 78%, and this is the number we enter into AMTS. If we multiply 78% by the NDF content of the feed, that would be our estimation of PENDF. But for this case, since the program does that, all we need is the PEF factor, and we can enter that directly. This is a very simple way to do it. If you look online, you can find these for sale, and some people I have seen try to make them. Some of the important things are make sure that they meet the specs of the official Penn State boxes, because it's very important for what the screen size is and what the depth of the screen or the thickness of the screen is as well. So they're very useful tools, and we recommend you using them for your forages to be able to get a good understanding of what the PEF factor is. So, thanks.